All right, so let's do another example. Number 3, I'm going to go ahead and write H sub 0 and then H sub A. An engineer has designed a valve. Oh, look at that. An engineer has designed a valve that will regulate water pressure on an automobile engine. Okay, they didn't give us any information yet about the mean. The valve was tested on 110 engines, and the mean pressure was 4.6 pounds per square inch. So just notice that sentence. They say the valve was tested on 110 engines. So that sentence, starting here and ending here, that's on our sample data again. That's information about a sample. And we don't want to put that information into the null hypothesis. So we're not going to use any of the numbers from that sentence. Next, they say assume the standard deviation is known to be 0.8. We're also not going to use that because we're looking for a mean, not a standard deviation. Okay, here we go. This is what I was looking for. If the valve was designed to produce a mean pressure of 4.5 pounds per square inch, is there sufficient evidence at the 0.02 level that the valve does not perform to the specifications? Okay, so keyword, the valve was designed to. If anything's designed to be a certain way, we naturally are going to assume that it works at that level. So the number for our null hypothesis is right here, 4.5. So for our null, we assume that mu is equal to 4.5. And then our alternative, is there sufficient evidence at the 0.02 level that the valve does not perform to these specifications? Does not perform. So they don't say overperform or underperform. They're just saying does not perform. They're not being specific about greater than or less than. So in that case, we just care about it being different from. And that's where we will use this not equals. Mu is not equal to 4.5. Is there just any difference, whether it's bigger or smaller? We don't care. We just want to see if it's different. Okay. So that's 3 examples on how to set up your hypotheses. Now, I mentioned before, in each of those problems, they mentioned this level. Is there sufficient evidence at this blank level? What is that? So scrolling down, I'll talk about it right here. The probability of rejecting the null hypothesis, even when it is true, is denoted by alpha. That's the Greek letter we like to use if we write it out. But that is referred to as the significance level of the test. The significance level determines how far out from the null hypothesis we'll draw that line on the graph. So for an example, to graph a significance level of 0.05, we need to shade the 5% of the distribution that is furthest away from the null hypothesis. And here's an example picture. So this is a two-tailed test right here because we have two tails. And as you'll see in the pictures below, I have examples of the other ones, but we'll get there in just a moment. Real quick, I just want to bring you back to when we did confidence intervals. If I can spell it right. So for example, if we had a 95% confidence interval, here's my curve. What that meant was, we had these critical values that cut up our graph. And if we had a 95% confidence interval, that meant 95% of the area lived between those critical values in the middle here. Or, if we translate that to a decimal, 0.95. And then we had, the area on the opposite side out here, we could figure that out. So like if 95% is in the middle, then 100% minus 95% gives you 5%. So that means there's 5% of the area in these two blue shaded pieces, right? So we did this with confidence intervals. It's just that we were referring directly to the 95%. And then you could kind of work backwards to figure out the area in the tails. Well, when we work with the hypothesis testing, when they give us the significance level, they're giving us the area in the tails, right? So a 0.05, 0.05 is equal to 5%. We just rewrote it from a decimal to a percent. And that means 5% of the area is in the tails. And look, that means 95% of the area is in between the tails, or between those critical values. So same exact idea from confidence intervals. It's just we're just looking at it in a different way. Instead of giving us the area directly in the middle, the significance level tells us the area in the tails. But like I said before, it's not always two tails. Every confidence interval we did had two tails. And all confidence intervals are going to have two tails. Now, stepping into hypothesis testing, that won't always be the case. We can have two tails, like this example down here, but we could also just have one tail. So right-tailed test, that's when we had that greater than. That's when we have a tail to the right. What a thought. And then the left-tailed test, same idea. That's a less than symbol, or it's pointing to the left. And we have a left tail. Okay, so one last little bit. I do have another page, but you can see this whole picture, and there's like a lot of stuff going on. And we're going to talk more about this when we actually start, doing these hypothesis tests. But essentially, what we're going to be doing is, remember I said that we will need sample data? Well, we'll find our critical values using the z-values, which I'll give you a little table of common z-values, just like I did with the confidence intervals, so we don't have to look them up 1,000 times. But we set up these critical values, and then we develop a test statistic from that sample data that we had. Like in this example up here, our sample data was a valve was tested on 110 engines, and the mean pressure was 4.6, and we're assuming the standard deviation to be 0.8. That was the sample data. We use that to create a test statistic, and then we see where that test statistic is. We compare it to our critical values. And if our test statistic lands in one of these tails, in a two-tailed test in either of the tails, then we reject our null hypothesis, as in that there's evidence to show that the null hypothesis may not, in fact, be true. However, if our test statistic ends up living, in this green area, or between the critical values, or not in a rejection region, then we fail to reject the null hypothesis. So a quick note on that. Notice the language I'm using. So once we, do this hypothesis test, we come to two options. We reject the null hypothesis, which means the thing that we were claiming to be true, there's evidence to show that that's not really true anymore. So we reject the null. However, if we don't have the evidence to show that, our claim, our assumed claim, the null hypothesis is true, then we don't say we accept it, right? We just say we fail to reject it. Because once again, the whole point of these hypotheses tests is to see if our alternative claim, our alternative hypothesis is true. Just because we can't prove that the alternative is true, H sub A, doesn't necessarily mean that the null hypothesis is true. It just means we didn't have enough evidence to show that the null hypothesis doesn't work. So, I'll reiterate that again as we go through more problems, but just remember, these are the main words we'll be using: either reject the null or we fail to reject the null. And one last little bit is I'm going to show here the steps. I kind of just talked about it with you, but here they are written out. The first step to any of these tests is figure out your null and alternative hypotheses. You got to figure that out first. Next, you'll specify a significance level. Now, in our problems, they're going to tell us exactly what that level is. But in the real world, and in the project that we were supposed to have, but we're no longer having this semester, you guys would have actually had to specify your own significance level. So just know that, oftentimes in the real world, you pick your own, but you'll be given the significance level for these problems. After that, we, identify the appropriate test statistic and figure out its value. We'll be learning about two different test statistics, the Z and the T, which we talked about with confidence intervals. So it won't be completely brand new in that respect. We figure out our critical values and we set up a decision rule. I'll go more into detail with that in the next section when we actually start working out these problems. And then from there, we make our decision to reject or fail to reject the null hypothesis. And then, state the conclusion. So there's quite a few steps to these problems, but if you just follow these steps every single time, you'll be golden. You'll be able to work through each problem. Okay, so the next video, we will start working through some hypothesis testing. See you then.